Salam alaikum. I hope it is working well. My voice is clear. So, as I said in the class this week, this is going to be a recording which is available to you all. Salam alaikum to everyone. As I said in this week's session, actually we need to complete three modules, but unfortunately, due to the time constraints, we are not able to complete the three modules, and we completed the module 10 and 11. So now here we have the module 12, and in this module, we are going to learn the concepts related to the physical and infrastructure security, and also how to do the security auditing and all. So this will be available as a recording, and I hope this will be helpful for you all. Okay, so now without further delay, let me start the session. So here we are going to cover the topics related to the physical and infrastructure security, as well as the security auditing and other mechanisms also. So now let us start with the physical and infrastructure security. Because if you remember in the previous two modules, we learned about the operating system security, virtualization security, cloud security, IoT security, and all. See, most of the discussions and most of the concepts that we learned so far, it is focused on protecting the software, protecting the network and data. But however, even the strongest software security can fail if the attacker gain a physical access to the system. So there are three major categories. Okay, one, the logical security; second one, the physical security; and the third one, um, the premises security. So the logical security is the protection of computer systems and data against the software attacks and the network based threats and all. After that, the physical security. So here the physical security means the protection of it is like the protection for the computer systems, hardware, facilities, and the people who use and maintain them from the physical threats and all, like for example servers, computers, network equipment, data centers, employees, system. So it ensure the attackers cannot physically damage or access the infrastructure. So then the premises security. See, the premises security is like the protection for the organization's buildings, facilities, people, and even the physical property. So the premises security will extend beyond the IT equipment. So here in this mechanism, it is going to protect the buildings, officers, employees, visitors, the organizational property, like everything. So in this process, the logical security is going to protect the computer data against the software based and communication based threat, whereas the physical or infrastructure security is going to protect the information systems, hardware, and personnel from physical threats and prevent physical access that could compromise the logical security. The premises security is going to extend the protection to the entire facility by safeguarding the people and property through the measures such as like perimeter security, access control, smoke and fire detection, the suppression, environmental protection, surveillance systems, and alarms, even the security guards. So it will be helping the organizations to meet the legal, uh, regulatory, and the fiduciary obligations and all. So now let us see more in detail about the physical security. See, the physical security, as I mentioned earlier, it is going to protect the physical asset like computer systems, network equipment, facilities, personals that support the storage and processing of the information. So here mainly the physical security focuses on protecting the hardware and infrastructure that make the information system in a possible way. So this asset will include, like as I said, server, computer, even the network equipments, data centers, all these things. And then it mainly The physical security is essential because the information cannot remain secure if the physical infrastructure that store and process it is vulnerable. So effective physical security require both protecting infrastructure from damage and preventing its misuse, ensuring the hardware, facilities and personals remain secure while it is reducing the risk of vandalism, theft, unauthorized copying, and now even unauthorized access to the sensitive information and all. Then there are various types of threats that we have under this physical security threat. See, here it is importantly, as we know, the physical security threats are the events, or it is going to be a condition that can physically damage or disturb the information systems, facilities, or even the supporting infrastructure mechanisms and all. So the physical security threats are going to be the physical situations and occurrences that threaten the information system. And these threats are grouped into four categories. One is the natural disasters, second one, the environmental threats, third one, technical threats, and fourth one, the human caused threats. So, when we understand all these categories, we can enable the organizations to identify the risk, and we can implement the appropriate physical security measures to protect their information system and support the infrastructure. Natural disaster in the sense, naturally it is going to happen. It is going to happen the events that can damage the information system and infrastructure. Whereas the environmental threats, if you see, the environmental conditions like heat that may damage the equipment or interrupt the operations. And the technical threats, if you see, it is like the failure which is involving the technical infrastructure that disturb the information system. And then human cause threat, so the human actions that physically damage or misuse the information systems or even the infrastructure and all. And then we have the characteristics of natural disasters and all. See, the natural disasters can be any type. So there are six common natural disasters are there based on the three characteristics. One is warning, evacuation, and the duration. See, the natural disasters will differ in terms of warning, evacuation, and duration. So the tornadoes, they provide advanced warning but require people to remain on site. The hurricanes often significant warning, or they offer significant warning and may require evacuation. Whereas the earthquakes, they occur without warning and it may prevent evacuation. Ice storms or blizzards. So it generally provides several days of warning, but it may make the evacuation difficult. And then the lightning, which offers only minutes of warning and may recur, and floods, they often provide several days of warning but can isolate the affected site for the extended period. So when you understand the characteristics of each natural disaster as an organization, it can you can improve the disaster preparedness and also the physical security planning and all. And then the environmental threats. See, environmental threats in the case, there are various conditions in the surrounding environment that can damage the computer systems, network equipments, and even other information technology resources also. So the major environment threats are inappropriate temperature and humidity, then chemical, radiological, and biological hazards, fire and smoke, water, dust, and infestation. See, the thing is that here the environmental threat is like a condition that can damage the computing resources, or it is going to reduce their performance as well as the reliability also. because the environmental threats include the inappropriate temperature and humidity, chemical, radiological, and biological hazard, fire and smoke, water, dust, and infestation. And these conditions can damage the computing resources. It can reduce the system reliability and it can interrupt the business operations. So, we need to emphasize that computing equipment has temperature threshold for damage. So when we highlight the importance of maintaining the proper environmental conditions to protect the information systems in an effective way. And then we have another category of environmental threats, that is water damage and chemical, radiological, and biological hazards and all. See, the greatest danger of water is it can create electric short circuit that damage computing environment. So when water comes into contact with electronic equipment, it may interrupt the electrical circuit. It may damage the hardware. It can cause the system to fail. It can cause the system to fail. And then the burst pipes. See, water pipes may break because of fault in plumbing, freezing temperature. So both the situations can flood the area containing the computer equipment, and the due diligence, like the organization should carefully inspect the building infrastructure to ensure that the water leaks from upper floors cannot damage the information system and all. And another category we have chemical, radiological, and biological hazards, and these hazards may affect both the computing equipment, personal equipment. So here hazards hazardous material may enter the facilities because of deliberate attacks, industrial accidents, equipment failures. See, the thing is that the hazard substances may enter the building through air conditioned systems, ventilation systems, open windows, likewise. So with all this, the water damage is major environment threat because it is primary danger, which is electrical short circuit. So water damage may result from burst pipe, accidental sprinkling activation, flood water containing mud and suspended materials, or the leak from upper floors, which require the organizations to perform the due diligence when designing the facilities and all. And the chemical, radiological, and biological hazards may arise from the intentional attacks or accidental discharges. So it will enter through the ventilation systems or even through the open window. And that flooding can introduce the chemical or biological contaminants, so which will make the environmental protection as essential aspect of the physical security. And then we have uh, another two categories. One is the dust and infestation. The dust and the infestation. See, in both of these, there are various considerations in both the categories. Like, for example, in our university, when they are renovating one building, okay, so during the construction, the dust will enter the nearby data center through the ventilation systems. Now, the IT department install temporary dust barriers and clean the server fans regularly to prevent the overheating. Because the region experience high humidity, facility managers also monitor for mold and mildew, while the pest control services inspect the storage rooms to prevent the insect damage to archive the paper records and all. So the dust is an environmental threat that is often overlooked, yet it can damage the rotating storage media, computing fans, and the block of ventilation. It will lead to the overheating. So dust may enter facilities through the nearby building demolition. The windstorm will be carrying the debris or construction and maintenance activities and all. And also that infestation includes a broad range of living organisms with high humidity promoting mold and mildew, and insects particularly affecting the wood and paper, which will be making environmental maintenance as an important part of the physical security and all. And then let us look at the technical threats. Okay. So unlike the environmental threats, the technical threats are going to originate from electric power problems and electromagnetic interference. So both of which can be affected the operations of computing equipment. So here a technical threat is going to be the problem which is related to the electric power or electromagnetic interference that can disturb or damage the computing equipments. So here these threats will include the power utility problem, under voltage problem, over voltage problem, noise on power lines, and electromagnetic interference. So these are generated by the source like motor, fan, heavy equipment, other computers, radio station, and the microwave relay. So which can cause the intermittent computer problems and all. And then we have the human caused threats, human caused threats and all. So here, unlike the natural or technical threats, the human caused threats are less predictable because they result from the human action. So they may be targeted and they are difficult to deal with also. Mainly, see, the human caused threats are less predictable. They may be targeted and they are harder, difficult to deal with than many other physical threats. So they include unauthorized physical access, which can lead to the additional threats like theft of equipment or data, vandalism of equipment, data, or misuse of resources. So preventing unauthorized physical access is therefore a key aspect of protecting the organization's information system and also the physical infrastructure and all. And then the mitigation measures in all these three cases are very important, or very important, because in each of the case we have seen different types of laws, right? So the mitigation measures are going to be the security controls that used to reduce or prevent the impact of all these threats. So we have three categories: the mitigation for environmental threat, mitigation for technical threat, mitigation for human caused threat. So the main purpose of these measures is to reduce the likelihood of damage and improve the protection of information systems and also the physical infrastructure and also the physical infrastructure. See here importantly, the environmental protection includes temperature and humidity control, fire detection and mitigation, water protection, and dust and pest control. So the technical protection relies on UPS systems, emergency generators, and EMI filters and shielding. So the human caused threats are reduced through the physical access control, protection of IT equipment, wiring, communication, and media, along with the restricted building access, which is a secured area, tracking the devices and introduce the sensors and alarms also. So then the recovery from physical security breach, recovery from physical security breach. See, despite all these preventive measures so far we have seen, the physical security breaches can still happen due to the natural disaster, due to the accidents, or due to the human caused incidents also. Human caused incidents also. See, the thing is that the recovery from physical security breach will be focusing on redundancy and physical equipment recovery, where the redundancy enable the recovery from data loss through offsite backup, regular update, batch encrypted remote backups, and in the critical environments. So the remote hot site with live data will be there. So the recovery of damaged equipment is always depend on the nature of the damage and the required cleanup, and organizations may need the assistance of disaster recovery specialists to restore the normal operations. And then in this process, we have the backup facilities. for the disaster recovery, we will be having the backup facilities. Because, see, we are mainly focusing on the types of backup facilities every organization that used to continue their operations after a disaster. So there are three backup facility options. One is hot site, cold site, and site sharing. So these facilities will help the organizations to recover their computing operations after the disaster, like fire, flood, earthquake, or even other physical security incidents that may happen. So importantly here, a hot site is ready to run, but which will have a very high cost. A cold site will provide the building facilities, power, and communication, but no computing resources. The site sharing will allow multiple organizations to share a backup facility, even though the computing incompatibility may become a challenge. So it clearly understood that the importance of keeping the backup tapes and other recovery resources at the remote site is required to uh, support a successful recovery and all. And then threat assessment process. Threat assessment process. So here, if you see, before an organization can implement the security before the organization can implement the security control or disaster recovery plan, it must first understand what threat it is facing, and that process is called threat assessment. So threat assessment is performed through the 8 systematic steps. Okay, and each step is very important without skipping each other. So here in overall, see, the threat assessment is going to handle with this 8 step process that begins by setting up a steering committee and obtaining information and assistance, followed by identifying all possible threats, determining the likelihood of each threat, estimating direct and cascading costs, prioritizing the threat, and finally completing a threat assessment report. And this structured approach will help the organizations to understand the risk and support the effective security and also the disaster recovery planning and all. And then the physical or logical security integration. The physical or logical security integration. See, instead of managing physical security and logical, I mean the cyber security separately, the organizations they integrate them both together. They work together as a single security system. So here, the physical or logical security integration means combining the physical security controls and logical security controls into one coordinated security system. So the organizations typically they deploy many different security devices, and these may include the physical devices like the door access system, alarm system, surveillance system, and they may also include the logical security system like user authentication, computer access control, and then network security. So, with all this, it will be managing all of this separately. That can be very difficult. That can be very difficult. So, the security works more effectively when all security devices are managed from one central location. So, instead of monitoring multiple independent systems, the administrators can control everything through a centralized management system so that the organizations they integrate the physical security and logical security, particularly the access control, so that the building access and system access can be managed together. Okay, so there is a need for security standards giving like FIPS 201 of one personal identity verification PIV, and which is of federal employees and also the contractors of a like as an example. So now if you look at this FIPS 201 SP 800 116, these standards describe the alternative authentication mechanism that can be used to control the access to the specific areas and all. So the FIPS 201 and NIST SP 800 describe the alternative method of authenticating the users before they grant the access to the secure physical location. See, the FIPS 201 and NIST SP 800 they both support secure physical access by defining the alternative authentication mechanism for the restricted area. So here we are going to specifically identify CHUID and CAK as an example of these mechanisms and all. CHUID is the card holder unique identification identifier, and CAK is card authentication key. So this is a part of the integrated physical and logical security systems and all. So these are used to verify the identity before granting physical access to the protected locations and all. And then the security audit terminology we have. See, we use the definition from RFC 4949, which is going to provide the standard security terminology. So a security audit is like an independent examination of the system records, and it is going to activate by evaluating whether the security control and policies are working properly or not, See, a security audit is going to be an independent review and examination of a system's records and the activities. So its main purpose is going to determine the adequacy of system control, whereas it is going to ensure the compliance with established security policies and procedures which can detect the breach in security services and recommend the appropriate countermeasures. So the objective of a security audit is to establish the accountability for system entities which is involved in security related events. So a security audit trail will provide a chronological record of system activities, and this will allow the investigators to reconstruct and also to examine the security related transactions from the inception to the final result. So data generation is the process of deciding what security event should be recorded during the auditing. So this function is going to identify the level of auditing, and it is going to list the types of auditing events. That means it is going to determine which system activity will produce the audit record. So then the event selection is choosing which event should be included in or excluded from auditing, and then the event storage is going to be like creating and maintaining a secure audit trail. After that, the automatic response, which is like uh, the action automatically taken when a possible security violation is detected, and then the audit analysis is automatically examining the audit data to identify the possible security violations, and then audit review, which is allowing the authorized users to examine the audit data. So the key thing is that together, all these functions will ensure that the security related events are going to be recorded, securely stored, automatically monitored for the possible violations analyzed and reviewed by authorized users to support the effective security management. And then the event definition, that is requirements. See, before an auditing system can record the activities, it must first decide which event should be audited. And this process we call it as event definition. Event definition. So in the event definition, it is the process of deciding which system activity should be recorded in the security audit log. So not every activity will perform by a system needs to be audited. Instead, the organization first define which event is important, which event should be recorded, which event should be monitored. Likewise. So with all that, the common criteria recommends auditing events such as like creation and deletion of objects, changes to the access rights and security attributes, security policy checking, use of privileges to bypass the policy checks, identification and authentication activities, security related actions by users or operators, and the import or export of data using the removable media, all these things. And then we have some more other audit requirements also, some more other audit requirements also. See, this is going to explain like what I can say, the additional requirements which required for the completed effective security auditing system. So the thing is that event detection hook are going to be the mechanisms that built into the software that detect and capture the system activities for auditing. And then um, the event recording function is going to record the detect it is going to handle the records the detected events and store them securely. So after an event is detected, it must be recorded and stored securely. So secure storage prevent unauthorized modification or deletion of audit records and all. So an effective security auditing system requires reliable event detection mechanism, secure event recording and storage tools for analyzing the audit trail, and the strong protection for the audit data, software, and storage themselves. So, additionally, the auditing processes should have the minimal impact of normal system functionality. So, this will be allowing the security monitoring without significantly affecting the system performance and all. And then implementation of requirements. See, the implementation requirements for conducting a security audit according to the ISO guidelines, because the organization should follow 9 implementation requirements to ensure that the security audits are conducted safely, consistently, and without disturbing the normal system operations and all. So the ISO implementation requirements will ensure that the security audit is going to be conducted in a controlled, secure, and objective manner. And this includes the obtaining of management agreement, defining the audit scope, limiting the production access to read only, using isolated copies for additional testing, providing the necessary resources, identifying special processing requirements, monitoring and logging all audit activities, then documenting the procedures as well as the responsibilities. So this will ensure that the auditor and going to be independent of the system and the activities are going to be audited. So by doing all these things, and it is conducted by independent auditors to maintain the integrity, security, and the objectivity of the audit process. So what to collect in this process, that is very important. What we need to collect, let me show you the example also. Yes, okay. So a security auditing system should record important security related activities that help the administrators to detect the incidents, then investigate problems, and ensure the accountability. So, the audit system may collect the data about auditing software use, use of system security mechanism, event from IDS and firewall systems, then system management, operation failures, all these things. So, a security auditing system will collect the important security related information because the auditing system record the activities related to the auditing software itself. This will help to determine when the auditing software is used, how it is being used, like all these things. So the security mechanisms will include the security features that use to protect the system, and their usage should be recorded. So with all these type functionalities, effective security auditing will be depending on collecting of information from multiple sources, as you can see in this example also. So it includes like system security mechanisms, network security devices, operating systems, applications, and even the remote access service. So while these provide the comprehensive visibility into the security activities, it also create the challenge of handling large volume of audit data that will be making a secure storage and efficient analysis, which is a very essential, which is a very essential. And then we have the concept of physical access audit trail. Physical access audit trail. So here, unlike the logical audit trails, which record the computer activities, in the physical access audit trail, it will record who attempt to enter the physical location like building, laboratory, or even the data center. So the main objective here is we need to understand like how the physical access audit trails are generated, what information they are recording, and how they will help the organizations to monitor and respond to the physical security events and all. See, the physical access audit will complement the logical security auditing by recording who attempt to enter a secure physical location, and when those attempts are happening, by centralizing these records, the organizations can detect unauthorized access attempts, monitor the changes to the physical access privileges, and automatically notify the security personnel when violations are happening, strengthening the overall physical security management and all. And then we have the concept of protecting the audit trail data. Protecting the audit trail data. Okay, so an audit trail is very valuable evidence during a security investigation. If the attacker can modify, delete, or read the audit log, the organization may lose the critical information about the security incidents. Security incidents. So audit trail can be stored by using various ways, by using like various mechanisms. Importantly, so the audit trail data can be protected using read-write files, write once, read many devices, or write only device, each with the different advantage and disadvantages. And it emphasized that the audit trail data must be protected both integrity and confidentiality, and also identify the encryption. So the digital signature and access control is going to be very important mechanism for achieving this protection, for achieving this protection mechanisms and all. So to ensure the trustworthy audit records, the organizations must protect both the integrity and confidentiality of audit trail data, which will be using encryption, digital signature, and the access control. So the implementation log is also very important. See, here we are going to understand The implementation logging, which mainly focus on how the audit data is initially captured before it is stored and before it is protected from the attackers. Because effective logging starts with the accurate and untampered capture of audit data at the moment security events are happening. So by placing logging hooks within software, the organizations can automatically record predefined events and they can build the reliable audit trails. Since different operating systems and application functions differently, the logging mechanisms must be tailored to each platform while maintaining the consistent and trustworthy audit records and all. And also we have the Windows event log mechanism. See, the Windows event log mechanism is the built-in login system for Microsoft Windows for recording the important system, application, and security events and all. So here we will understand the structure of Windows event logs and we will identify the three types of event logs that used in the Windows event log mechanism process. So a Windows event log is a record where it is going to have the important events that happen within a Windows system, within a Windows system. So the Windows event log will provide a very detailed and structured way, as you can see in the example also, to record important operating systems, um, application and security events. So by organizing the events into the system, application, and security log, the administrator can efficiently locate the relevant information during the troubleshooting, performance monitoring, and the security investigations. So each event is stored as a structured record containing the identifiers, attributes, and the optional user data, which will be making analysis more systematic. So the Windows event categories are there. Windows event categories are there. See, it is very important that different categories of Windows security events that can be recorded in the Windows event log. Windows event log. So the thing is that the Windows categories audit information so administrators can quickly locate a specific type of event during the security monitoring and also during the investigation. So by separating the authentication, account management, directory access, object access, policy changes. So the privilege modifications or process activity and system operations into the distinct categories where the Windows will provide a structured approach for the auditing and also for troubleshooting, for the auditing and for also troubleshooting. And then we have the concept of Unix syslog, Unix system log. Okay. So previously we learned about Windows event log for Windows systems, right? So here this one is going to provide the logging mechanism for the Unix or Linux systems and all, Unix and Linux systems and all. See, the syslog is going to be the general purpose logging mechanism which is used in either Unix operating system or Linux operating system. It is available for both variants, even though logging facilities and log formats may differ. And we are going to identify four key components of syslog. Four key components of syslog, that is syslog API, which is used by standard systems, utilities, and application programs to generate the log events. The logger, which is going to be the command that is used to add the single line entries to the system log, and then /etc or /syslog.config. This is the configuration file that control the logging and routing of log events and all. And finally, we have syslogd, which is the daemon that receive and route the log events and all. See, it is available on all Unix and Linux variants and consists of the syslog API for generating log events, the logger command for creating manual log entities, the /etc syslog.config configuration file for contributing logging and routing, and the syslog-d is going to be the daemon for receiving and routing the log events and all. And then the security auditing is also going to happen here in this case. See, we need to understand the basic services that a security auditing system should provide and introduce various additional add-on features that can improve the auditing capabilities and all. See, a security auditing system is always provide three essential services. One is capturing the relevant events, storing and auditing the data, and transmitting the syslog message from multiple hosts to a centralized syslog server. So which also identify, we need to identify the optional features that enhance the auditing capabilities, including robust filtering, log analysis, event response, the alternative message format, the log file encryption, and the database storage and rate limiting. So here, that is why a security auditing system, security auditing system provide the essential services of capturing the relevant events, securely storing of audit data and transmitting the syslog messages to the centralized syslog server. So it may also include the advanced features like robust filtering and then log analysis, event response, alternative message formats. With all this, it will help to improve the effectiveness and security of the auditing process. Now, logging at the application level, logging at the application level, we are going to see. See, the application level logging is also very important because the operating system logs alone may not be capturing all the security related activities that are happening inside a system, inside the system. So the operating system logs will provide only a partial view of system activity, and many security problems will happen inside the application. So particularly in privileged applications where vulnerabilities such as improper input validation and error occurs. So the application level logic or logging complements the operating system auditing by recording the detailed internal behavior, which will be giving the organization's better visibility into the application specific security events and all. See, the thing is that we need to make sure the interposable libraries, interposable libraries we have. So this allows the generation of audit data without recompiling either the system libraries or the applications, because when you have seen the application level logging, it is necessary because of the operating system logs alone cannot capture the internal behavior of an application, right? So the first approach to collect the application audit data is the interposable libraries. So here the interposable libraries are especially valuable when the organizations require to audit commercial or third-party application that cannot be modified. So by intercepting shared library function calls instead of changing the application itself, so the organization can collect detailed audit information while preserving the original software, then we have dynamic binary rewriting mechanism. So here in this process, the dynamic binary rewriting process, it provide a flexible way to collect the application audit data without changing or recompiling the original application. So by modifying the executable only in memory at load time, the organizations can audit existing software while preserving the original executable file. And it is very important that the Linux implementation uses a loadable kernel model and monitoring daemon to handle the process. So with modules automatically loaded and unloaded as it is required in the mechanism. Then the audit trail analysis. See, so far we learned how to audit the data and how we can collect the data using techniques such as interpretable libraries, dynamic binary rewriting, all these things. See, collecting audit logs is only the first step, whereas the organization must analyze these logs to understand the system activities, to detect the security incidents, and to identify the unusual behavior and all. So collecting audit log is only the beginning of the auditing process. Effective audit trail analysis always require interpreting log entries into the context, correlating the information across the multiple sources, handling different log formats, and reviewing the logs regularly to understand the normal system behavior, which will establish this baseline to help the organizations to identify unusual events more accurately and improve their ability to investigate the security incidents and all. See, we have various tools and the integrating approaches, all these things to handle the audit trail analysis and review. So with this, we completed the module, and this will be provided to you all as a recording. So soon, I think I will post an announcement regarding this. Okay, thank you.